Good afternoon, everyone. Good afternoon, sir. Good afternoon and welcome to the day 7 of the Faculty Enrichment Program on Concerns of Academic Research in Social Science, organized by ISS College of Teacher Education, Perindalmanna, Kerala, and Khaja Bandhan Nawaz University, Kalaburgi, Karnataka, in collaboration with Farooq Training College, Kozhikode, Kerala, and MESS Pillai College of Education and Research, Chembur, Mumbai, Maharashtra. My name is Surekha Chidambaranath, and I am an assistant professor at MESS Pillai College of Education and Research, Chembur. The last 2 days, we learned about how to use SPSS for data analysis. But as sir mentioned, that purchasing such softwares can be costly. But there are some open and free sources which we can use for data analysis. So the topic for today's discussion is free and open source softwares for analyzing research data. And our resource person is Dr. Thiyagu. Dr. Thiyagu holds the degrees MSc in mathematics, MPhil in mathematics, MEd, MPhil in education, MSc in psychology, PhD in education. He has 11 years of teaching experience in various organizations. He was the Faculty of Education on Contract and School of Education and Training, Central University of Tamil Nadu, Tiruvallur, and Tamil Nadu before joining CUK. His main areas of specialization are educational technology, educational psychology, research methodology, educational statistics, educational administration, and mathematics education. He has published 75 articles in national and international level journals. He has presented a paper in 125 international and national conferences held in various parts of India. He has published 3 books earlier in the area of ICT in education. He has acted as a resource person for various levels, seminar and conferences. Sir, I don't think we could have anyone else other than you for the session today. I request you to start with your session. Thank you so much.
Thank you so much. I hope my voice is audible to all of you. If you have any technique,
Yes,
it's kindly
absolutely.
inform me. Yes, fine.
Yes.
Thank you. Just I'm sharing the screen. After that, I may share my views related to the free open source software. Yeah, so just I'm closing the wanted screens. Yes. So the topic which is assigned for me is today free open source software, particularly how to do the data analysis with this kinds of free softwares. Because yesterday, I hope last 2 days, you may have the experience how to use the SPSS for the data analysis. And particularly today I'm focusing some of the free open source software which may helping for do the data analysis. Particularly I'm talking about quantity data analysis, how we can do the similar kind of quantity data analysis in the case of free open source software. This is my agenda of my presentations. So normally when you go for presentation, I may make some kind of agenda. Here just I made some kind of agenda for my presentations structure. The first I just start with small beams. In what way the people struggle to finish that research work, and which are the problems we may face while doing the research work. That's for only maximum 5 minutes. And when you're thinking about the ICT integration in the case of the research, we can divide basically into 3. One is called before the data analysis, that's called pre-data analysis tools. And during the data analysis, which are the tools might helping for us. And the last one, after the data analysis, we can go for the writing the research work for, that is called as a post-data analysis. So if you're thinking about the research, we can divide into 3 spectrums: pre-data analysis, and during the data analysis, and last is the post. Similarly, when you're thinking about the ICT integration while doing the research, we can use the different kinds of tools for the pre-data analysis tools and data analysis tools, as well as the post-data analysis tools. But today I'm focusing on only the second part, that's called during the data analysis. Especially, I'm going to highlight during the quantitative research, how we can use this kind of free open source software for doing a quantity research, how to handle this kind of quantity data while using this kind of free data softwares. That is mine. Then finally, I can come with end remarks. So generally, when you're thinking about the research, most of the peoples, they may be finish the end moment only. So the first 2 years, even I have the experience in my personal experience, I finished my PhD in the 4th year only. The first 2 years, I didn't start it yet. Just I started some preliminary works only, but I didn't start it very deeply about the research. So the similar way, most of the researcher, they can do the similar kind of things only. So the end moment only the peoples like us, we may finish the things, right? And the next thing, most of the cases, the problem with the people, um, based on the convenience of the guides, the scholars might be change the topic, because every topic is not cup of tea or cup of coffee for all the researchers. So we may be competent in some areas, but due to the force from the guide or external sources, we may be change the title. So it is not be fair, because based on the convenience of the research only, we have to be take a research work. Otherwise, this kind of issue may be facing. And piece look like a puzzle box, especially when it come to the data analysis. The people struggle in what kind of data analysis we can do for this kind of objectives, for the basic objectives and all. And most of the people confusing what is their objectives, hypothesis, and which is the appropriate statistical analysis for the particular objectives. They have the confusion. That is the reasons I use the term piece to look like a puzzle box. The people knows the way to join, but they could not find the way to finish the figures. This is a biggest challenge in the case of the PhD scholars. Even the project work, some of these guides may be doing some project work, they also having this kind of issues. And now, do you know, after the UC Catalyst, the biggest challenge to the peoples to publishing a research article in the Scopus or Web of Science or UC Catalyst. It is not at all easy, but even though the people struggle to get a single publication for 1 or 2 years, it's not at all easy now. Previously, 10 years before, publications very simple. Even there is no UC Catalyst and all. That is the reason we are sending some qualitative journal, quality based journals, and we get the publication. But now we have the limited UC Catalyst. That is the reason it's very big a challenge to publish an article. And when you go for publication, also there is issues that, particularly the Scopus Web of Science, after 1 year, after 1.5 years, they will send you a response like this, right? So your article is good, but it is not met our scope of the journal. The final moment after 1.5 years, they may be rejected. So this kind of issues comes because sometimes we may not be selecting a appropriate statistical tool, appropriate techniques for doing this analysis. That may be issues. And main issues in the case of online, because the online, when you go for Google Scholar or any kind of database, particularly for the research, we may get more number of research article in this our particular area of research. But the issue is that we cannot find which is a more appropriate for us, which is more meaningful research article for us. That is the reasons the people struggle to find the appropriate or the exact research work which is already done by someone people's. Okay, so this is a bigger challenge for the people. And yeah, just I'm moving to the main focus: free open source software. The advantage of free open source software is totally free, and if you are very good in the coding, even you can modify the structures of the interface. Even you can write in coding, and you can add some more what is that statistical features into the existing softwares. That is the advantages while using the free open source software. So as I already mentioned that, and just to leave this kind of basic introduction, what is ICT tool also, because you're already familiar. And just I'm making this, when you look onto the ICT integration to the research, we may divide into three: pre-data analysis, data analysis, post-data analysis. But now I'm focusing on the only the during the data analysis, which are the ICT tools, especially I'm focusing on free open source software, which is more good for as me. So therefore, I'm going to my 50th slide directly. So here I'm talking about some of the tools which may help him for doing the data analysis. And when you're thinking about data analysis, we have the different, there's a two different spectrum. One is called quantitative data analysis, other is qualitative. But in this section, I'm focusing only quantitative. So when you're thinking about the quantitative data, we have some of the basic statistics in our mind, like SPSS, R, MATLAB, SAS, GraphPad, Microsoft Excel. These are the tools we may hear, because these are the tools regularly we are here from somewhere, from the net sources, or some of our friends maybe spell it. The issue is that out of this much of tool, we are using only one tool as a free tool, is called R. And the R tool, no, most of the people may came to know that. But the issue is that it's not that much of user friendly. If you know the coding or the programming, then only you can much comfortable with while using this kind of R tool for the doing data analysis, because normally most of the people's not their cup of coffee is not their programming. So writing the coding, it's not their things. That is the reason most of the people they move to the SPSS, because the SPSS is a graphical user interface. Once you click this path, you may get this answer. Even the last 2 days, you have the experience how to use the SPSS for doing the data analysis. So that is the reasons most of the people may be using SPSS as a paid version or the crack version they're using, but the crack versions, if you're using, it's not be good, it's an unethical. While doing the research, you should be ethics. We should be use the some of the license softwares only. So SPSS, we have the license, but that amount is so high. Even for 1 year for the single users, nearly 10,000. I'm talking of the basic statistics. If you like to go with the SPSS subscription, it comes more than 10,000 rupees per year in a single user. So therefore, it's much expensive. That is the reason the people's not going forward to use this kind of SPSS as a license version. So that is the reason I'm just introducing some of the free software. This much of free open source softwares are available. Even I'm shared this link to you, the finally JASP. So the tools, it is totally free, and Jomovi, and even what are the advanced statistic analysis which are incorporating into the SPSS, even the SPSS new version is 29, the latest version, the SPSS is called 29. The similar kind of regular update it happened, this kind of free software, especially JASP, Jomovi, OpenStat, SolStat, so far, PSB, it looks like SPSS, the same kind of interfaces. But when you go to the JASP and Jomovi, there is a small difference in the interfaces compared to the SPSS. But the PSBB same like that SPSS, but you could not find this latest features which is available in the SPSS and the PSBB, because the PSBB they are not doing regular updates on them. Then StatText, microseries, G-numeric, Tanagro, and AM statistics software. This much of software is totally free as part of the qualitative, it's a quantitative research. Just I'm sharing my one of my website link that I'm already compiled all the websites. 1 minute, just I'm sharing this websites for you. So my website's called digigogi.info. So in this, I'm already keeping a separate page. If you need, if you want, sometimes you maybe forget what are the software which I'm emphasizing there. That is the reason. Just I'm sharing on link to all of you. This is a links I already combine all the free softwares. I'm just sharing in our chat box. So 1 minute, sharing to the chat box. So hope you may be receive this link. Once you click this link, you can get this kind of interfaces. I already compiled all the free software. So because within near 2 hours, I could not be cover the entire software which I like to highlight here. So that is the reason I'm giving us a link. I request all the participants kindly click and explore by yourself. Even I learned this kind of free software by myself only because of the YouTube videos. A lot of videos are there. So learning by ourselves, it gives you the conception understanding about the research as well as this kind of tools. So I am requesting all to be explored. And the first tool is called Jomovi. If you want to know more about this, if you click this Jomovi, this link or this link, it automatically goes to the Jomovi web page only. So if you click it here, it goes to the Jomovi web page. So this is called stats.open now. This is a company's developed. This is a job. Even we can use it for a cloud-based desktop-based. Desktop means we have to install and we can use it. Cloud means we can use it online. So now they're giving us a beta version online. Now, especially those who are using SPSS, no, the latest version is the trial version. The trial version of the SPS is only 30 days. The 29 version, if you are using it, you should have the internet. Without internet, you cannot use the trial version of the SPS. The similar way, this Jomovi cloud, we need internet. With this, we can use it. And the other one is for Jomovi desktop, we can use it for offline. So like this, there's two kinds of software they're providing us. And one more things here, it may be supported to all the CRAS platforms. It may be supporting to the Windows OS. It may be supporting to the Mac OS, even the Linux. For any kind of OS, it may be working it. So if you want to more about this, we go to the features, you can see these features. So even it working with our syntax. Suppose you want to know about the products, you can click the Jomovi cloud. If you need to download, click the Jomovi desktop. It goes to the download view. Normally they're providing a salad. Salad means it's like a default, like a permanent or some kind of static version of the software. If you like to go with the beta version, because the beta version regularly updating, so the latest version, latest update you may be getting the beta version, that's called current. So my suggestion to go with this solid. Okay. Suppose if your system is to be new and if you like to explore more about the statistical analysis, you can go with the beta version like current. And what is the advantage which I already mentioned? It may be supporting to Windows OS, Mac OS, Linux, and Chrome OS. So therefore, for downloading is very simple and installing also very simple. So just I'm sharing this, the downloadable link of the software. Once you click it here, it may be downloading. After downloading, you have to be installed. The installation maximum takes 2 minutes only, maximum 2 minutes. After the installation, you can find this kind of icon. This is an icon for the Jamovi. If you click it here, you can see this Jamovi interface. So this is Jamovi interface. So this is one software which I like to introduce for you, and gradually move to the other software also. So this is a very simple user face, very simple user face. And similarly, just I'm showing this SPSS because sometimes you might know what is the exact difference between the two views, SPS and Jamovi. I'm having the trial version of SPSS. Just you can cross check in what way the SPSS and Jamovi is to be different to each of us. So just I'm moving to the SPSS. So I'm using the trial version for the 30 days trial version of 29th version. The latest version is 29. Okay, so it's opening. As I already mentioned that we need the internet, right? So for using this trial version, we need the internet. So I went for the subscriptions. So it asking the username, password. Once you give the username, password, we can able to go with this, the home page of the SPSS. So this in one. So still is opening SPSS. And we're waiting for this. Yeah, so it takes time. But the difference, the main difference among this SPSS as well as the Jamovi, it is very much user friendly in the case of Jamovi. See here, generally in the case of SPSS, you can find more number of menus. Just see here, this is my interface of SPSS. So when you go with the SPSS interface, we have the three views like data view and variable view. If you go with the latest version, you can go with the overview. So there may be a three view in the case of the home page. Data view, variable view. The previous versions only two, data view, variable view. Now we have the latest which is called overview also there. And there is one more view is called as the output view. So there is here three views basically in the SPSS. And see here, there is a menu: file, edit, view, data, transform, analyze, graphs, utilities, extension, windows. This much of menus are available while using the SPSS, and it creates a lot of confusion because even if you click this analysis, we have the different kind of analysis like meta-analysis, report, descriptive analysis, Python statistics. Now they recently added the Python statistics, but this is already there in the case of Jamovi. Even in the case of JASP, it is already there. And the issue is that when you click in the analysis in the SPSS, we are not using this much of statistical things. But we have the confusion, which is the things we can use the distributed statistics, when we can use the, which is the path we can use for the independent sample titers, even the ANOVA, ANCOVA, MANOVA, like this, a lot of confusion becomes because lot of menus, it creates a confusions in the case of SPSS. And, but you can see here, Jamovi interface, this is a Jamovi interface. It is very simple. We have only this much of menus: variable, data, analysis, edit. So only this much, only 4 menu bar. After the 4 menu bar, if you click this analysis, everything comes to the icons like explorations, nothing, descriptive statistics. When you like to do the t-test, we have the independent per sample t-test and one sample t-test. If you like to go with the ANOVA also, we have the different ANOVA, one-way ANOVA. Even in the case of SPSS, if you like to go with the one-way ANOVA, you can go with the mean comparisons. There only you can find out the one-way ANOVA. But here there is a separate option for one-way ANOVA. ANOVA, in this one-way ANOVA, multivariate ANOVA, then repeated measures ANOVA, ANCOVA, MANCOVA. Suppose you like to go with a non-parametric parallel, we can go with Kruskal values or Friedman. Similarly, if you like to go with non-parametric for the independent sample t-test, we can directly go here. Independent sample t-test itself, there is here options like a man-Whitney U-test and all. So see here, there is a man-Whitney U-test. So therefore, we can do parallelly parametric and non-parametric together. That is the advantage while using this kind of geometry. But in the case of SPSS, we can go with a different path. Just I'm showing this for the SPSS. So in this SPSS, you can see if you want to do the non-parametric test, you can go the different path, right? So non-parametric test, from this we can go with one sample, non-parametric independent samples. Like we can go the different path while using non-parametric. But here in the geometry, it is not like this. The same path we can use it. So just I'm opening my geometry. See here. Suppose I like to do the independent sample test. In the independent sample test itself, a manual test. So there is no need to do a separate path, calculations in the case of non-parametric. While doing the parametric itself, you can find a non-parametric calculation. Suppose you like to go with the parametric, non-parametric, based on the normality, we can select it. And there is for the regression analysis, this for the frequencies. Frequency mean like two binomial test and chi-square goodness of it. This for the factor analysis. Even we can go with the principal component analysis, explorative factor analysis, confirmative factor analysis, all kind of statistics possible. Suppose you need to go with our syntax, you can go with our syntax. And suppose you need to go with some kind of structural equation modeling, like look like almost there is a module, separate modules are there in the case of geometry. Even we can install this kind of geometry. See, just I'm showing this how to add some kind of addition, like add in software or action software in the case of SPSS. If you go to the geometry library, we have this much of geometry libraries that like scatter or to JPower, JAMI. Suppose you like to go with structural equation modeling, just we have to be installing. And if you like to go with the Bayesian method or FXIs calculations, which are the add-in software we need, just we can install and we may get one more icons here. So like this, we can explore and we can do any kind of higher order calculation, even doing the meta-analysis also is possible. So this is a way the geometry interface is useful for us. I'm doing one demo after 15 minutes. Okay. Now I'm just introducing only the interface of the different softwares. So this is a basic interface of the geometry, and I'm moving to the another software. Just I'm closing this geometry. Yeah, so I'm moving to the other software. That is a software name. It's called JAS. It's my another one of my favorites tools called JAS. Okay. Just I'm showing this. So here the JAS. If you go to my website, so I already shared this link. Hope you are getting my link. If you want, I can share this link once again. This link, all the software links are available. So suppose you like to explore the JAS software. Yeah, thank you. So if you click the JAS, it leads the another page. So JAS web page. But compared to the geometry and JAS, the interface wise look like the same. JAS and geometry interface wise look like the same, but the colorfulness, like when you go with attractiveness, no, it will be available in JAS because some kind of colorfulness is there. If just I'm opening a JAS software, just so you can look onto this. I'm already installed the JAS software. So this is a JAS software. This is a geometry. I'm opening both. So I'm opening both. This is a JAS software. See this colorfulness and see this the geometry. The geometry only the basic color black and white and blue. So everything is a blue menus, and the other things like a grain color. So most of the things are green color. But see here geometry, it's totally is very attractive. When you do this data analysis, you can understand how it will be very colorful. Even the graph and all, we may get the different colors. Okay, but just the basic colors like one or two colors only is available. We cannot go with more number of colors in the case of geometry. But the interface wise look like the same. So the same, like see here, all the menus are like descriptive, t-test, ANOVA, mixed modules, and regression analysis, the factor analysis. These are the same menus are available in the geometry. See here, and just to move to the geometry. The geometry exploration, t-test, ANOVA, regression, frequency, factor, right? The similar kind of menus are available, even the JASP. So just I move to the JASP now. Descriptive statistics, t-test, ANOVA, mixed model, regression analysis, frequency, factor. Even if you like to go with meta-analysis, reliability analysis, then structural equation modeling and visual modeling, there is a plus, as I already mentioned, the geometry. The similar way we can add different add-ins software. Once you click it here, we have the different add-in software. which are the add-in software, just you can enable it, automatically comes as an icon. And just I'm briefing how to download this JAS software. If you go to the JAS homepage, this is JAS homepage link. I'm sharing this. If you click this link, it goes to the JAS interface, the homepage interface. There is a download options, right? If you click download, it takes few seconds to be download the software. After that, you can go for installation. So similarly, this is also taking you maximum 2 to 3 minutes for installations process. And another thing, even if you go with SPSS, when you after the installations, we have to do some kind of coding. So like a license, we have to copy and paste, or we can copy the ISLR file into the C drive and all. So like this, lot of confusion it's happened while installing SPSS software, even the license one or in a crack version. But here is very simple. Once you download and click it, it takes maximum 2 to 3 minutes. You can go to the next. There is no need for license. There is no need for any kind of code to be copied in the C drive or either. Nothing is needed. Just you can press click. It goes to the installations. Once installation is done, you can go back to the your downloaded view and click this icon. This is a JAS icon. This is a Java. So I hope you are getting these two icons. This is a logo of this particular tool, right? So, and what is the features while using this kind of JAS software? See here, it is totally free. JAS is an open source project supported by the University of Amsterdam. Actually, this is a tools developed by, there is a set of scientists, particularly for the Department of Psychology, Psychological Method Unit, University of Amsterdam, and a lot of sponsor also there. This is the advisory board of this thing. Okay, and regularly they're doing the updates. And the first importance of open source software is totally free. You don't need to pay a single paisa for this. And the another one, it is a very friendly user interface compared to the SPSS. Just I'm showing once again the SPS interface, because the last 2 days you already have the experience how to use this things and all. Just I'm showing one example about SPS of 29 version. So if you go with the 29 version, see this file, edit, view, data, transform, analysis, graphs. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There is 11 menus. Out of 11 menus, the basic statisticians, they may use maximum 4 menus only, like analyze, transform, file, then graphs. So we are using 4 menus only. But this much of menus create a lot of confusions among the learners or among the users. But the JAWS is very simple because see this interface, there is no menu bar. Actually, the menu bar here is come as say only the directly say icons only. All the analysis, descriptive analysis, status, ANOVA, mixed model. Suppose you like to go with the main menu, this is a main menu. So like a pancake menu. So if you click it here, you can see this. If you want to import the data, you can go to open. If you want to know about this software, I'm using this 2022, the last year version. So the 15th version built on Netherlands. Okay. So it is developed by the University of Amsterdam. So like this, we may know what is the latest, which version we are using as in JAS software. And so this interface, as I already mentioned, is very simple, friendly. It's a JAS is an intuitive interface that designed with user in mind. Even the laymen can work. Even the people not much about the computer skills that people can use in the JAS, because the SPS is not that much of user friendly in the case of the laymen or the basic computer users. And the other one is a flexible. So what is that flexible? Even there is two kinds of analysis, like a classical and Bayesian. So see, if you go with the latest version of SPSS, it's the latest version of SPSS, there only you can get this in Bayesian statistics. So the normally we use the classical statistics, but the classical statistics we have the descriptive, everything we are using the classical. But now the people like to go with the Bayesian statistics also. So it's based on the probability basis that people like to go with it, they can use the Bayesian statistics. So, but now only recently they added the space of Bayesian statistics. But here, when you do this data analysis, then you need to see just I import one data, then you can understand. I'm already imported one data, just I'm added this data. After importing the data, you can see this in when you like to do the descriptive, t-test, automatically get the classical calculation Python. Even the ANOVA, there is a classical Python. Even if you go the regression, we have the classical Python. There is a two kinds of statistics are available, but the traditionally we use the classicals. Okay, so normally the SPS also it may be much supporting the classicals. So we can go with this. So this is an interface and see the colorfulness. Okay, so there is a different, very unique colors when you use the Jamovi. So this is a data view. Yeah, so this is like the JASP interface. Similarly, there is other softwares. I'm doing the demo with the use of JASP after the 15 minutes, just to introducing the different softwares now. After this, I'm doing all the calculation from descriptive statistics to regression analysis, even the factor analysis I'm doing with this JASP. Okay, so you can wait for a few minutes. Just this here time I'm using only the intro about the different softwares. And the other software is called Blue Case Statistics. So particularly if you want to go with desktop-based free software, you can go with this. So this is called Blue Case Statistics. If you click it here, it goes to the Blue Case Statistics download view. Similarly, it may be working with both cross platforms like Windows, Mac OS, and all the things. So there's a black Blue Sky Statistics link. There you can download this software. Okay, so their interface little different. Particularly if you like to go with the higher order calculus structure equation modeling and other things, you can use it. And this is it working with the paid as well as the free also, and it is both the options are available. And similarly, other softwares like our software, that's knows. So once you click this our software, then we can go to the R projects. But as we already familiar with, some of it is already familiar with our projects, we need some kind of basic coding idea. Then it's easy for the people to use the data analysis. So I'm sharing this our project. Here we can install the different add-in software as well as the source software or softwares in that. So similarly, there is another softwares like GNU PSBB. This is software same like SPSS, but they are not updating regularly. So you can try with this PSB pre-L has been released now. So just you can click this link and download it. So this is a downloadable view. And they may highlighting which are the latest versions are available. If you click the download, we can find out this downloading view. Then free has a freedom to replace the proprietary program SPSS and PS very similar. That is the advantage when you use the PSB. Those are already comfortable with the SPSS. They can easily follow the PSBB. The same interfaces. So it's very simple for the users. And because the SPSS is a paid one, it is a free one. Then another one is called SOFA. If you click this SOFA, you can see this another software SOFA. And it's like the basic strategy, you can use it. Okay, so we had to go for download of SOFA. And similarly, it might be working with the different cross platform like Windows, Mac OS, as well as the Linux also. See this. Once you download it, automatically based on your system configuration, it may be downloading the software. So here, you can get this basic statistics only, not in higher order things, that we can get some kind of basic statistics. Because instead of using a SOFA, I'm using a Jamovi and JASP. That is I'm not installing because there is no space in my laptop. Otherwise, I can do the interface. It's me working the basic statistics. So you can try with this. And another softwares like Devel. There's another software. Just I'm sharing this link. Devel.net. Okay, this is another software. So we had to be click and download. So basically, it may be good for the certain graphical representations. We can use it. See, like mean, sample count, standard deviation, median, then minimum, maximum, the will cause and man very near. These are the basic statistics also available. And better, it will be good for the this kind of diagram representation. Okay, for this, the people are using a Devel software. And these are the free software. Which I like to emphasize now. But out of these two things, just I'm doing the demo from the basic to the higher level calculation with the use of the JASP. And similarly, if you have the time, I can do the demo with the Jamovi also. So kindly check, okay, because suppose I'm not cover the Jamovi, don't worry. Suppose I'm not having the time to be cover the entire Jamovi, I request the participants kindly click my website. If you click it here, I already keep it all the Jamovi software tutorial. So another link, I'm sharing this link also. So here you can get this, the entire tutorial. So the basic tutorial to the higher order, even if you go with the factor analysis, up to the factor analysis, I already made a small PPT, I already uploaded here, right? Once you click it here, you can get a lot of insights how to do the Jamovi. So because as I already mentioned, the Jamovi and JASP interface look like a same. Once you experience in the JASP, you can easily follow the Jamovi. Or once you have the experience Jamovi, you can easily follow the JASP. The interface wise, the same, but only the colorfulness to be different. Suppose you want to know about Jamovi more, there is a free books also given a hyperlink. Just you can download and download this book. The entire tutorial is available as a Jamovi book. So here I already uploaded. So just you can see this. Suppose even if you cannot find how to use a Jamovi with my content. So I'm already connected with my Jamovi website. They already given the different different tutorials. It is developed by the Jamovi team itself, like how to install navigations. Everything is available. Just you can click and download and learn by yourself. So all the modules, I kept it as a videos here. Once I click it here, you can know how it will be working it. So this is here Jamovi software. Similarly, if you like to know more about JASP, I'm already made some other link, JASP software. This for the JASP. I'm sharing this link. Once you click this link also, you can get this entire JASP website and how to install it. And I already connected with some of the GIF files, like small videos, how to do the correlation, how to do the descriptive statistics. Everything I added is here, small hyperlink. Just you can click and find out the video file as well as the GIF file. So hopefully it will be useful for you. So kindly visit the sites. You may get more insights about how to use the JASP and Jamovi. Right now, I'm directly moving to the demo part. Are you ready? Are you ready for the demonstration part? Are you ready? So if you're ready, you can put R in the chat box. Other than this, I'm just comparing different tools also, like stat text micro series. Thank you for pressing the Jasa. So hope all are ready for exploring the tool Jamovi or JASP, right? So after installation, please kindly note, just I'm closing all. So then you can realize how to do this. Okay. I'm closing the other unwanted screens. Okay. Yeah, just I'm minimizing. Yes. After the successful installation is over, you can go to the your My Computer. Suppose you are using these Windows, go to the My Computer and find out this icons, JASP or the Jamovi. So just I'm over to the JASP interface. So once you go with the JASP, just I'm closing this because I already opened, that is reason to open. I don't say, yeah, I'm opening a new interface. Once I click the JASP, you may get this empty interface of the JASP, right? This is a JASP interface, right? JSP. And as already mentioned that the 3 F's is to be very relevant. It's a free, it is a friendly as well as very flexible. Even if you like to do classical or Bayesian calculation, you can do up to you now. And the first thing, how to import a data. Suppose I'm already having one Excel file. Suppose you like to do parallelly along with my demo. Suppose some people like to do parallelly along with me. So I'm already uploaded the data sets for your purpose. So if you go to the SPS tutorial, because I'm already having some SPS tutorials. If you comes down the SPS tutorial page, I'm already compiled some of the data sets for you. So this are data sets. Okay, if you go to this link, you can get this some kind of sample data sets. The first data sets only I'm going to do the demo. If you like to download, just you can click, it goes to the Microsoft, sorry, this one, what is it? Google Sheets view. There you can download it. If you click it here, it goes to the Microsoft Sheets, not Microsoft Sheets, like a Google Sheets. Then you can go to the download button. Once you press download, you can get this kind of Excel file. So this is an Excel file. I'm going to do the demo. And similarly, this is an Excel file only I'm going to do the further calculations. Suppose you need to write a interpretation based on the APA. I'm already keeping a different APA styles interpretations. There is a SPS tutorials PDF format is available. If you want, you can click basic statistic graphical representation inferential. I already made some PDF file. Suppose if you need to write an interpretation based on the APA style, you can use this as a PDF file. You can download it. It's a free and make it as a Creative Commons license only. You can use it without my consent. Now I'm moving to the. I'm already downloaded that particular Excel file into my desktop. See this in my desktop interface. So in this desktop interface, I already download data sets, XLS and desktop CSV. So generally, this particular JAS software, it may supporting to the .csv file or .sav. Even the SPS is a data file also you can upload it. But my always suggestion, because it's not directly working with the XLS file like Excel file. Therefore, after opening a normal Excel, what you have to do, you can go to the Save As. In the Save As, you have to be paste this, save this particular Excel file in a CSV format. That's called delimited CSV format here to be saved. So after selecting the CSV format, go with the save. So because it may be working with the CSV file or any other format other than the XLS, that is the reason I am telling to be save as a CSV file. So here the CSV file, the same data sets available. Now the first steps, just I'm going to upload the data, how to import a data into the JAS. Okay, so I'm already having the Excel sheets that how I'm going to be importing. So this is a main button. There's a main menu, look like a pancake menu. If you click the show main menu, you can get this option called open. Please kindly see my interface. There is a open. So in this open, they're given a different options like a recent file. Suppose if you already open a recent file, if you want to open the same file, just you can click recent files. Similarly, the SPS also the recent file options are there, right? And suppose you like to upload a file from the computer, and then from the desktop or any kind of C drive or D drive, we can go to the computer. Then we can go to the browse and select the specific file. There is an OSF. They already have some kind of repository in the OSF. There, if you're creating username and password, even that particular data sets, we can use it for to do the calculation. Even the data set is not prepared by yourself. It is already prepared by someone. It's already available in some database that we can use it. And they given here some kind of trial or some kind of demo data sets for us. Suppose you like to go with the descriptive statistics, status, ANOVA, regression, frequency analysis. For all the things, they're given some kind of basic data library. Even we can use this one. Okay, suppose you want to explore it, you don't have data sets. That particular JAS itself, they're providing some kind of basic data sets. This also we can open this. So once you click the descriptive statistics, we can get small data sets. Just you can click and open it. But I'm just uploading my data sets, which is available in my desktop. So for this, I'm going to the computer and go to the browse. So if I go to the browse, it asking to go to the desktop. In the desktop, I'm selecting this CS because see here only the CSV files to be enabled. I'm selecting the data sets final CSV, the same like Excel file, and click open. Once I click the open, the same data sets is available, right? So here, this is a variable sample. I have the 1000 sample, gender, qualification, locality, management, college type, residence. These are the variables, right? So the similar way here, the row is a sample. So the basic condition row should be a sample, and the column should be a. This is a basic for all the status. When you do for any kind of software, it should be type the row in the sample representation, and the column should be variable. This is a basic understanding we must know. If you're typing wrongly, the output becomes, but totally the calculation which you've done is wrong. So the basic assumption that column we have to be typing a variable, and the row we can treat it as a sample representations, right? And see here, the basic simpleness of this JAS. Even those who are knowing the SPS, can I know how many views in the SPSs in the case of the data view? So there's a two view, as you know. One is called data view. Please, I request the participants kindly involve and give the answer in the chat box also. We can learn what is that both together, right? So please, if you have some question, kindly type in their answer in the chat box. So generally, the case of SPS, this is a SPS view. If you go with the old version, there is a two view. One is called data view, other one is called variable view, right? In the variable view only, we have to define, for example, if I click it, the variable view, we have the measures like whether it's like a nominal data, ordinal data, interval, everything we can define it here only, right? But for this, we can go with a variable view. Then only we can make it. Thank you, Faizan, sir. I request others to be interact like this. So if you want to do any kind of editing in the variable, we can go to the variable view, even for the name, type, width, decimal, everything we can make it changes here, right? Suppose, for example, I'm just making a small demo. I'm just making a say 111 for 5 variable 1 1, right? So 1 1 1, so 1, so 2 2 2. So just I'm adding a first variable. So I can define like this. So here I can go with gender. In the gender, I have to define one is a male. So this is what, like this, we can do this, right? So we have to be add like one is a male. Then it is a new format. That is the reason we are getting this. One is a male. And if you go with add, then 2 is a female. So this is a way we can defend it, right? In the case of SPSS, right? So we have to do this kind of things. Then if you go to the data view, you can see this. So now you can see this male and female. This is an SPSS view, right? Hope you know how to do the SPSS. But now we can see I'm doing the JASP interface. Here there is no separate pan. This is called data pan. So instead of a view, they're using the term pan. Okay, so just I'm typing this. So this is called data pan. So they're using the term data pan. Okay, so in this data pan or data view, there is no separate variable. Suppose you want to define 1 equal to male and 2 equal to female. So there is no need to go with the variable and change it. Please kindly note, just you can press the gender. Once you press the gender, there is a one more pop-up window there above. There you can just made it 1 equal to male, 2 equal to female. So I'm defining directly from here. Now you can see the changes. Are you able to see the changes? So even the SPSS, if you like to do the same changes, you have to do 2 or 3 steps. Then only it may be changed. But now you can see it's very simple. Once it's selected here, it automatically changes. Suppose I like to change the qualification. You can press qualification once. That's enough, right? And go with the qualification UG and PG. See this how much easiness, right? So now you can say automatically UG PG might change. Now you can understood the easiness or the friendliness of this JASP software. Suppose you want to go with the locality, you can go to the locality. So once we press the locality, so in the locality, or management, click this management. Suppose the management, once I click it here, and just made this management government, aided, self-finance. Right, self-finance, right? Like this, we can define it, okay? So self-finance automatically comes here. And another thing, so already knows that in the SPSS, we have the 3 kinds of scales. Just I moved the SPSS. Now you can see my SPSS, right? In the SPSS, if you want to change the measures, so go to the measures, we can go with the scale, ordinal, nominal. So nominal is a categorical variable like nominal data. Suppose you want to change ordinal, you can go with the ordinal. The scaling variable, our steady variable is a scale, like continuous variable is called scale. Actually, the gender is a nominal. Therefore, we can select as a nominal. Yeah, exactly. Present just the sir. The JAS SPSS outputs are same, the similar kind of SPSS. And the another advantages in the case of JASP, we may get a customizations, like because like we have to get the dynamic output view. But in the case of SPSS, take a statistic. Even some of the statistics is not needed, but the SPSS may give us all the outputs. Even that output, there is no need, but we may get it to 4 or 5 tables, just we can copy and paste the Word document. But here, which are the table you need, we have to be modified, or which is the way we have to modify the table. That's I told the term dynamic output is possible in the JAS, but in the SPSS like a static output. There is a special structure, that is the way the outputs may come. Yes, now we can see this. As I already mentioned the SPSS, so suppose we want to do the measures, we can do this. But here, see, for changing this kind of things, I can go to the data view to variable with the SPSS, but I can see the JAMOV. I move to the JAMOV interface, but gender, it takes a nominal, qualifications taking nominal, but the locality also in this case, it is a nominal. It is not a ordinal. Why is taking ordinal? Because there is a 3 numbers, 1, 2, 3, that is the reason it's taking an ordinal. But you want to modify a nominal scale. So what I'm going to do, please kindly note screen. I'm not doing any kind of click here, look like a SPSS to the variable view. Just I'm pressing this icon. This is an icon near to the locality. Once you press it, automatically asking that whether this variable is ordinal or a nominal. Just you can select the nominal. For changing the measures, very simple. I'm changing all the measures like nominal. Now you got it. How I'm changing this? Suppose there is a scale is an interval, just you can select and change it in ordinal. sorry, it's an ordinal. Suppose if it is a continuous scale, kindly changes the scale. So it's very simple process to change the measures, right? It's very simple process compared to the SPSS. I hope you understood, no? So when you do for any kind of further analysis in the case of SPSS, we need to define properly whether it's a nominal data, ordinal data, or interval or ratio. Generally, the interval ratio is coming to the continuous, therefore it is called as a scaling variable. So we can add as a scale. But here we can easily change whether you need to go with ordinal or nominal. And see the sample, actually the sample, it is not a scaling variable. Even the number 1 to 1000, that is taking the scale, but it's generally is called nominal because each number is represent one sample, right? So therefore I'm selecting as a sample. Now you can see I have the gender is a categorical variable, qualification categorical variable, locality, management, college type, residence, everything is here. Up to the residency categorical variable. And study habits is a continuous data. Achievements is also continuous. Intelligence continuous. Therefore, these three come to the scaling variable, scale variable. So everything we can find it from here. This is here one view. That is a view. Suppose you want to close this span. There's an into button. Just you can close it. We feel that 1 and 2 instead of 1 and 2, you like to modify 2 and 1. Just you can modify this order. Now you can see this an order, reverse order, that also it's available. You want to close this span, just close this. So this is a main interface, like a data view interface. Do you have any doubt in the data input and data pan? If you have the doubt, you can ask me in the chat box. I'm moving to the another level calculations. So just now I brief it how we can import the data into the JAS, as well as the in what way we have to do the customization in the measures and how to define the variables. Yeah, thank you, President Michael J. What about others, please? No need to type no, sir. You can type N. Those single letters is enough. Please, I request to type. If you have a doubt, you can put yes. Please kindly ask the doubts. So kindly respond in a single letter. That is more than enough for me. So yeah, by saving the Excel file is CSV file. Exactly, sir. So or suppose you have the file in here already in the case of SPSS output, SPSS data, that we can import it directly. So no need to be changed because it may be recognizing the different files like CSV, even the SAV file, but other than the Excel, that is the reason I'm telling. Suppose, see here, suppose you want to save this. So now I have done everything. I want to save this data sets. Similarly, the SPSS data set we are saving is a .SAV, right? So here I'm saving the file into the computer and go to the browse and whether you need to give the data sets fine and click the save. So now the data set in the JAS file format, it will be saved in my desktop. You can see there is a different format like JAS. So data set final.jsp. I hope you have seen this data set final for .jsp. This is a file format after saving this. Suppose hereafter, suppose I'm closing this data sets. So I'm closing the entire journal. So enter JAS. You want to open and do the further analysis. Already the data set saved. Just you can click, double click. You can open here. Yeah, such app store. So just I'm accepting this. So we have to give this permission. Okay. For the app store. Okay. Just I'm open with JAS. Otherwise, one thing I can do, I can just open from JAS here because there may be issues in my laptop. It's asking to open. Just I'm opening the JAS in my interface. Then I go to the browse and open, and I'm just clicking the computer and go to the browse. There we can find out this file type. See here. So now previously only CSV file embedded. Now you can get the JAS file. So you can select the JAS and click open. So now the JAS file is coming there. Okay. So now I import as a JAS file, JSP file. So this in data view, right? So are you ready for the descriptive statistics? I'm going to the descriptive statistics. In the case of descriptive statistics, we can go with this menu. Just I'm opening my SPS also. See here in the SPSS, suppose you want to do a if you want just I import the same data, then you can understand how that output and other things to be differ. I'm opening SPS also. Just I'm opening the same data sets in the SPSS. Yes, I'm opening the same data set in the SPSS. Yeah, so I'm just to continue and continue. I'm just closing this because it's asking to import it. So I'm just to close and open a new one. Yeah, sorry, I got it, the new file. So this is my SPSS view. It is my SPS view. Just I'm closing this one. Save changes and no, okay. Yeah. So this is a SPSS file. So this is a data view. This is a data view. This is a variable view, right? So when you like to do the further analysis, we can go to the analyze, right? In the analysis only we can do this calculation, like when you do for the meta-analysis and all things you can do here only, right? The report, descriptive statistics and all. But now we can see here in my interface, I'm just moving to my data sets. You can see here, this is my data set. If you like to go with the descriptive, press the descriptive. So once you press the descriptive, there is a two views come here. This is called analysis span. This is called result pan. So just to introduce the two more term for you. So one pan is called analysis, okay? Analysis pan. So we can do under the analysis path in this analysis pan. The other one is called result pan. So we can get this output. That's called result output. Okay, result pan is nothing but the output of the results. So the left side is here analysis. The right side is here result, right? Now, I need to be getting here the frequency calculation, because as he knows that when you go with the descriptive, there is a different kind of descriptive statistics. One is a basic, like a level one, and just level one of descriptive, it's called frequency. So I'm just typing. I hope my chatting output is coming also. So the level one, the basic descriptive is called frequency. So the basic assumption when like to the frequency analysis, the data should be categorical. So the categorical data, it's nothing but the nominal or ordinal. Okay, so then only we can go with this kind of what is that level one, that's called frequency analysis. So for this, I go with gender, qualifications, locality, management, college type. These are the basic categorical variable. Just I import it, and because for the categorical data we cannot do the mean and standard deviation. That is the reason I'm just clicking the statistics in this. I'm removing the default mean, valid. These are things not needed. Only for the continuous data sets only is possible. So I'm removing the descriptive statistics, the other unwanted mean, median, mode. I need only the frequency table. Just you can select the frequency table. Once you select the frequency table, we can get this output like male, female, then UG, PG, then management, government, aided, self-finance, then locality, college type, residence. I hope you are getting this right. So like this, we may get here the level one frequency output in the case of JAF, right? Then this table is here APA. So the same, if you go with the APA, that's an American Psychological Association. They have the standard seventh, like now we are using the seventh version, I mean seventh APA annual. The same format. If you want to copy the result, you can copy this result. There is option called copy and export results. You can do this entire copy or the export results. The export results come to the Excel or it will be HTML file. Then after the HTML file, you can convert into Word file. That is very simple. So suppose you want to copy one by one, just you can click and copy this one. Okay, one by one. The entire output means you can go to this results and copy this entire output. So now I got the level one of the frequency distribution. Suppose I need to do some kind of graphic representation for this frequency data analysis. For this, we can go to the statistics. Statistics is for the statistics. You can go to the plots. If you go to the plots, please kindly see the I'm doing parallelly. This is called customing. What is that? I told no. There is a term which I introduced called dynamic. Suppose in this output there is a output like a gender and qualification and locality. Suppose I don't need a qualification. What I'm doing just you can go to the back and remove this qualification. Automatically the output may reduce from the qualification. But in the SPSS, if you done first time the qualification, it may consider. If you want to delete, you can delete manually. Or if you do once again the other calculation, from this the frequency may left. But here, suppose I remove from gender, automatically my dynamic view, it may be change the output. So only it comes the locality only. It start from locality. There is no gender. Suppose you like to add gender now, select the gender and track it here. Then there is called dynamic view. So what the learners users are expecting, that is the output you may get into this. outputs, right? So now we can see there is an output of gender in the loss. And other one, there is a plot. So that he knows the basic graphic representation for the categorical data. So some people, the issue is that if you are not aware of the basic statistics, the output may comes. The issue is that we cannot know which is the statistics more appropriate. There may be thumb rule for any statistic or even for the graphic representation. For the categorical data, we can do only case of the pie diagram or the bar diagram. So the categorical data, you can go with pie diagram or what is this bar diagram. So here you can see this, there is a heat map. So which is the diagrams more suitable, that you can select it from here, right? So here the display, this is for the title heat map. There's a 2 axis needed, and there's a scatter plot. There is a pie chart. So for me, we can be able to do only the pie chart. Therefore, I'm just clicking the pie chart now. Once I click this pie chart, you can see this output. You can see this output. There is a pie chart for locality. There is a management pie chart. There's a college type. There is a resident. There is a gender. All the pie charts are available. But if you go to the internet plots and QQ plot is meant for the categories data. That is the reason I'm now selecting it. So for the category data is possible only the pie chart or in a bar chart. So now this is okay, right? The level 1 of frequency, level 1 of descriptive. I'm going to the level 2. So the level 2 means message of center tendency. So message of center tendency means mean, median, mode. And level 3 means message of dispersion, like range, quarter deviation, then percentile. This are the compared to the message of dispersion, message of variability. And there is a level 4 of the descriptive statistics called checking the skewness kurtosis. Is nothing but skewness and kurtosis distribution. For checking this distribution, so I'm putting this level 4 is a distribution analysis. So for the distribution analysis, we can check the skewness and kurtosis. And level 5, we can check whether any kind of outliers are there or whether the data set is showing the normality. For checking this, there is a level 5. So there may be a descriptive study, there may be 5 levels. The level 1 is the frequency. The frequency is only meant for the categorical data. By the level 2, level 3, and level 4, and level 5, like a message of tendency, message of dispersion, or message of variability, or for the finding the distribution like skewness, kurtosis, or normality, your data should be a continuous. So the basic assumption, our data should be continuous. Then only we can go with it. Therefore, level 2 to level 5, our data should be continuous. So are you ready for the level 2 of calculation? Are you ready? Still now we are discussing about the level 1, let's get frequency. Now I move to the level 2 to level 5. For this, if you want to close this pan, you can close this one, or if you like to minimize it, you can minimize it. I'm going to add one more pan, same descriptive. See here, I'm adding the first pan, the descriptive status. Suppose you want to see this previous descriptive, you can go this. If you want to minimize it, you can minimize it. Now I'm going to the new descriptive statistics as part of the continuous data, right? So I'm going to the continuous data. Out of this continuous data, the steady habits is my continuous data. Then achievement is continuous and intelligence continuous, right? So once I add this, our default, you may get this some output. Right now, as we know that that frequency table is not possible because the frequency table is only meant for categorical data. Therefore, don't press the frequency table. Don't click the frequency. Instead, I'm going to statistics. In the case of statistics, as I already mentioned, that the level 2 is called MC, message of center tendency. In the case of message of center tendency, we have mean, median, mode, right? This is knows. If you want to select mean, median, mode, you can see when I select the mean, median, mode, automatically you're getting this output. Suppose I don't need a median, just you can remove the median might be left. Are you able to see this? Kindly type it. Suppose I need a median, I can select this median. This is called dynamic output. What you need that users can decide. But in the SPSS, default everything may come, so you have to copy and paste, and we can do the further editing the level only. But here we can do what the expectation from the users that they can do from the analysis. For example, I don't need a mode. Just so I can remove this mode, the modes may be left from here. So the level 2 is over. Now I move to the level, level 3. That's called message of dispersion. Are you ready? MD. Message of dispersion, he knows range, So if you come to the dispersion, there is a separate heading. That is an advantage here. Even the SPS, this kind of difference is there, but I don't know how many views are viewed. But here they given like a user friendly. The message sentence is a different heading. Mess up dispersion different heading. For this, I need standard error mean, variance, range, intent quarter range. So range, which are things you want, you can select it. I hope you are seeing this. Suppose I don't need IQR. You can remove this IQR, automatically the IQR is going. That's going intent quarter range. Right. If you want to go with the MAD robust, which one you want, just you can select and then go with this. And in the third level, there is a quartile. Suppose you need to go with the percentile. Once you click the percentile, you may get a percentage. So suppose like to go to the 25th percentile, 75th percentile. So what are the percentage you need? Just you can type here. You can get this answers 25th, 75. Are you able to get this? Are you able to see this? The 25th percentage. This called percentage means the portions. The portions of this course. So I got this the portion 25th. Suppose I don't need a cut. I need a cut points. Go to the cut points. So I'm just removing this. There is a 4 cut points. Suppose you feel that I need a 10th percentage, 20th percentage. I need all the 10th percentage. Go with the 10th, 10 equal. You may get this all the percentage. Or you see this 10% to 19%. Suppose you need to get a 50 percentile. Go to the 50 equal percentage. You may get the second percentage, fourth percentage. This is an advantage while using this JASP. I hope you are exploring this. Suppose I need only the 4, and just I'm going to the 4. Yeah, I'm getting only 4. So that is called dynamic user interface. What you need, you can select this. Yeah, now the third level is over. I move to the level 4. As already mentioned, the level 4 is a distribution, right? Level 4 is a distribution in the case of descriptive. So here are you able to see the distribution like skewness, kurtosis. Even there is here to tests for Sapir-Whorf analysis in the case of normality. Hope you know in the SPSS, the Sapir-Whorf analysis there for checking the normality. If you click the Sapir-Whorf, you can see this. That is called level 5 also. So level 4 and 5 is together is the skewness, kurtosis along with the Sapir-Whorf. So in this case of Sapir-Whorf scores, you can see this. This is here achievement score, study habits. This is here achievement. This is a p-value of Sapir-Whorf. This is a p-value. This is it's like a not significant. So not significant which is both the things satisfying the normality. Okay, it seems that checking the you are taking as a hypothesis that your distribution satisfying normality. Even it's satisfying the non-significant. Therefore, even null hypothesis is accepted. It seems that your distributions are normal. Then we can go for the parameter studies. This is the things we can get from the Sapir-Whorf analysis, right? Now, up to now, we are discussing about the statistics part, descriptive studies. Suppose you need to go with a diagram representation of this kind of continuous data. So in the case of continuous data, if you want to do a graphical representations, we have the option called plot, right? See, this is a plot. Even this an option is not available in the SPSS. If you want to do the SPSS, see, I'm just going to the SPSS. Suppose you want to do a graph in the SPSS, you can go to the graph, and in this you can go with a different box plot or in a histogram. You can go with the different, right? Even for histogram, you can go with this graph. If you like to go with the pie, if you like to go with the bar, we have to go with a different path and get into this. For the SP, this is an SPS output, right? SPS view. But see here, I'm just going back to my plots, right? I'm going to my plots. Okay. In the plots, 1 minute, just I'm added on. Yes, I'm just moving this one. Yeah. So just closing this, the previous one, 1 minute. Because I'm added one more descriptive, that is retention. Yeah, now I'm going to this too. Okay. Now here I'm already adding descriptive statistics and just like to go with a diagram representation. And there is a one unique graph. I don't know how many people have it. That's called stem and leaf. So even for stem and leaf itself, we can understand the normality. So once you press the stem and leaf, you can see the study habit stem and leaf, the study achievement stem and leaf, and intelligence stem and leaf. You may get it. So you can see the stem and leaf. It's like a frequency. Actually, there's nothing but the frequency. So the meaning of this graph, for example, if I go with this study habits, 145, actually 14.5. It's in the 145 this much times. 146, 147, 147 comes to 4 times. 148, it comes to 6 times, 7 times. 149. This called 150 2 times. 151 2 times. 152 3 times, 153 3 times. So we can find it from the number of frequencies. Instead of with the frequency table, we can get the stem and leaf, and just you can draw this graph in this mode, look like a normal probability curve. So normally we are doing the graph this mode, right? Please kindly see my hands movement. We are doing like a this mode, but here you can draw like this a view. You may get the same kind of normality. Even suppose you draw with a graph like, please kindly see my curves. Suppose I'm doing the normality analysis, it comes like this, right? That distributions. Similarly, this is a distribution. So this is one advantage. Even for checking the normality, we can use the stem and leaf graph. This is stem and leaf, it looks like a number, but it's a very good stem and leaf graph. Right now, just I'm moving to this one. Another plot, if you go to the plot, so this is another uniqueness. You could not find this much of features in the SPSS. See here, suppose I'm going to the distribution plot, like a normality for the, this is nothing but our home, what is that? Histogram. So I'm just going to the histogram. So in the histogram, I'm selecting the distribution plots. Now you can see the distributions. Are you able to see this distribution graph? This is called histogram, right? In this histogram, I want to add the above is called normal curve. If you click this display in density, you may get this. Now you can see this, how it's changing my graph. So the above it's called normal. And display rug mask. Suppose you want to make say display rug marks. So you may get some kind of rug marks also. And suppose you want to get the QQ plot. QQ plots normally we are using for checking whether the data set satisfies normality from. So the QQ plot is available in SPSS. If I click the QQ plots, you can see the different QQ plots for the three variables comes to the QQ plots. So now it's come. Now you can see for each variable there's a QQ plot. Are able to see the QQ plot for the steady habits. So from this we can easily to write the interpretation, because most of the data sets is lies above the diagonal line, right? So therefore it's satisfying normality. And similarly, there's a dot plot. Suppose you like to go with the dot plots or interval plots, you can go with any graph. See, this in advantages. So here you can see the dot plot. Suppose you need to go with this is sometimes we may get this one. We may have the doubts whether we need to go with the box plot to checking the outlier. It's very good. You can go to the box plot. We can easily find the box plot. From this, we can identify the outliers. So now just I'm getting this box plot, this and box plot. So the box plot is nothing but this is a Q1, this in Q3, Q4. So it's neither highest score, lowest score. In between the data may be static. Suppose you want to go with how the scores are distributed, you can go with the violin elements. You can get these violin elements in this graph. And if you want to go with the user color palette, you can click this user palette. The graph may be changed. Okay, you can wait. You can see here the dot. This are dot plots. So it's very. Then if you like to go with the color blind alternative or color blind, which one you want? Color blind is fine. The jitter elements and label outlays. So if you click it here, you can get this very attractive box plot. See here. Suppose I don't need a violin. You can remove the violin elements and jitter elements. So the graph might be changed now. Okay. This is called dynamic view. So based on the things which you selected, it may be changing, right? So now you can see this. So it takes few seconds to be changed. Now you can see this very attractive graphs representations are there. Now your graph, now you can see the violins may be changed, right? So previously like a violin, now you get this exact box plot graph. So this is called low score is an highest score. This is called Q3. This is Q3, Q1, Q3. The mid is called Q2. So like this, the box plot consists of all the quartile along with the highest score and lowest score. And we can easily find whether any outliers. Unfortunately, there is no outlier also. It's good. So I didn't find any outliers in mine. So here there is one outlier. There is an outlier. So that we can do. See, there is a one outlier. So there may be a above the 260 scores, it might be outlier that we can remove from the data sets. So this is why we can get this. Suppose you want to get a heat map. Normally the heat map is good for the correlation. So suppose you want to check the correlation between the two variables, you can use this kind of heat map. Okay. So like this, we can do the descriptive statistic with the use of this JAS. Do you have any doubt in the case of descriptive statistic? I done all the levels, level 1 to level 5. So how to do a what is this continuous data for this I done a demo. I hope you understood. Those are understood, you can put you in the chat box. Otherwise, you can ask the questions to me. Sometime you may have the doubts. Sir, yeah, you done only for the continuous data is fine, but you need to be, I need a male separately output, female separate output. There may be chances. Suppose you do the continuous control group and experimental group, you need two different output, like control group output and experimental group output. So like we need to categorize by the category variable, there may be doubts might comes. It's very simple. Please kindly see my interface. I already made this three variables, continuous study habits, achievement, intelligence, right? Suppose I want to split the entire output into two, like male and female. I can select the gender. I can put to the split file. Once I split the split, now you can see my output, the dynamic output is modifying. So it comes the two output. I hope you are seeing this. There is a male output, female output. Achievements male separately, female. Intelligence male separately, like a control group experimental. Even the graph, even you can see this graph, there is a male graph separately, female. This is a female graph. So previously every graph is a single graph, like only the entire 1000 sample you may get this graphic eruption. But and now I'm getting the two graphs, male separately, female separately. Even the box plot too, male separate, female separate. I hope you understood. You understood the display. If you have the doubt, please kindly ask me. So the entire output is comes to two, like based on the split file. So because I'm adding the split file. And one more good thing, sometimes we may have the doubt. So sir, whether I can add this continuous data into the split file. You can see this. Already they given the split file, only the two kinds of data. There are two icons only. One is called, so thank you, President Das. Please, others also, please, if you have doubts, kindly ask me. I don't know, because I'm talking, but I don't know whether you are understood or not. Please kindly respond. You can ask some question I want to learn from you. Even you can add some more points which you're familiar. Kindly give some input for me. I'd like to learn from you also, please. So here, suppose I like to go with the qualification, just you can input qualification bits comes to two different output. And another one, as I already mentioned, that it's very simple here. We can, even the layman's can understand whether I can upload a data. For split file, it's only possible two icons only. One is for nominal, one is for the interval. We cannot what is that, keep it the scaling variable here. So because even the layman's can understand what kind of data sets we can keep it here as a split file. So this is a basic what is that, even that's the reason I told even the layman's can work with this tool, because like very much user friendly. Now I move to the t-test. So I'm just started with independent sample t-test. Independent sample t-test. So you know there is a three kinds of sample t-test. One is called one sample t-test. There is a one sample. The other one is called independent. The other one is called dependent, or it is called as a post sample. So there is a different name, dependent or post. So there is a three kinds of t-test: one sample t-test, independent and dependent. So in the case of one sample t-test, we are comparing with because normally the t-test means the comparing means, comparing the means of two groups, right? So here the one sample t-test, it is a comparisons between the sample mean versus population mean. So this is things you know, right? So one sample mean, there may be a comparison between the sample mean and population means. The population means we can find it from the previous theories or previous secondary data. From this we can understood, right? But the sample means only like a primary data we are getting to this. But the population mean we can find it from the some secondary data only. So now suppose I like to do this t-test. I'm going to the t-test. So suppose you like to go with the one sample t-test, click the one sample t-test. I'm just keeping as a steady habits. I'm putting the achievement, for example, the achievements. So I'm keeping this achievement. You can see this achievement. The T score is 251, but I need to be defined what is my test value. So I'm just giving this test value. Before that, I want to know descriptive also. So yeah, online. So I'm giving us a 81 as a test value, like population mean. This is 81 is nothing but the population mean. So just I'm selecting here. So you can see this. Actually, the mean sample mean 75. The sample mean is 75. This is descriptive. And in the case of population means 81. That is the reason showing the difference. See here, the T value is my 17.681. Don't take it in direction, only taking as a magnitude. And the degrees of freedom 999. and the p-value is less than 0.00. It's like significant, right? It's significant. Therefore, there is a significant difference between the sample mean and population mean. Suppose I can just keep it as a 75. So the test value, I mean population mean, I'm keeping as a 75. Now you can see this output. When you're keeping the 75, there is a significant at 0.05 level and not significant at 0.01 level. So just I'm putting 75.5. Now you can see this, that different. So now the population mean is 75.5. That's called test value, that we can type it. And this was the sample mean, that's called 75.68. Now the t-score is 0.59 and the p-value is 0.55. So therefore, there is no significant difference between the sample mean and the population mean. So we can easy to understand the difference because the p-value is less than 0.05, so greater than 0.05 and 0.01. Therefore, it is called not significant. Therefore, null hypothesis should be not rejected. So it seems that there is there is no significant difference between the sample mean and population. So generally, this kind of calculation they're using for the business or the economics they're using. So in the education sector, we are now this is the one sample. Now I move to the independent sample t-test, right? So I hope you understood how to do the one sample. I'm just moving to the independent sample t-test. So here independent sample t-test, we needed two groups, like a group 1 mean. So we have to compare with the group 1 mean versus group 2 mean, right? So this is called independent sample. We needed two groups. So, but the one sample, we need a mean sample as well the population mean, or means sample mean and population. But here we need two groups, like a male mean and female mean. Then only we can do the comparisons, right? So now I'm moving to the independent sample t-test. Please kindly see this. I'm just clicking the independent. So once I click the independent sample t-test, we have the options dependent variables. So see, that's why I told once again, it is user friendly. Now you can see the dependent variable. So what kind of icon? This is a scale icon. This is a scale. Therefore, the dependent variable should be this like a basic assumption when you do the t-test. When you do the basic t-test, there may be two assumptions, basic two assumptions. One is a dependent variable should be a continuous, independent variable should be a categorical, right? And that categorical also only two groups is needed. Right now, I'm just keeping a steady habits as a dependent variable because it is a continuous, and the gender is a independent variable, is a grouping variable. Right now, you can see there is a t-scores automatically comes now. The independent sample t-test is 0.869, and degrees of freedom is no n1 plus n2 minus 2. There is a formula therefore 998, and the p-value is 0.385. It is not significant. Not significant means both the groups are both the means are same, like male mean and female means are same. If you want to get the descriptive statistics, if you click the descriptive, you may get the descriptive. Now you can see there is a descriptive male, female, n, mean, SD is there, and standard error is also there. And one more thing, even the SP this is there, like if you click the location parameter, that is called, we may get this kind of output, the confidential interval. If I click this location confidential, you may get this, the main difference. From this also we can write the interpretation. For example, the lower is minus 6.5, the upper is 2.5. In between there is a chance for the 0 because minus 6 to 2, in between zeros may lies. If the zeros, the lower and upper interval, there is a zero slice, it seems that no significant. Therefore, instead of writing a P interpretation, we can write the interpretation based on the mean difference also, because in between zeros comes, therefore it is called not significant, therefore null hypothesis not rejected. And another advantages while using this while using Jamovi or JASPA, we may get this effect size, particularly when you like to do the experimental method, we need to do effect size calculation because the title itself effectiveness. Because most of these the people is not doing the effect size. But my request to when you go with the effectiveness study, better to find the effects size calculation, particularly the Cogan's D. And it's meant for the experimental method, but I'm just doing how to do this in the survey method also. And once I click this effect size, you may get this Cogan's or class delta and heads. Which one better to be Cogan's D? So we may get the Cogan's D. So in this, there is an interpretation. So the Cogan's D is minus 0.06. It seems that it's already not significant. Only the zero, very low, very not any kind of what is that? Any kind of significant effect is not made in the case of the independent variable gender into the dependent variable. So that is a meaning because it's like the effect is only 0. very zero. This is like a nullified effect. There is no effect in the case of the things. Okay. And parallel, if you want to check whether you like to go with the one tape test or two tape test, even the SPS, this is the, suppose you like to go with a one tape test, you can go with this kind of non-direction hypothesis. Suppose you like to go with the direction hypothesis, like when you go with the experimental method, control group is better than the experimental group better than control group, like this, you can go with some kind of direction hypothesis. You can go with this one, group 1 to group 2 for the direction hypothesis, but I like to hear the testing possible only the null hypothesis. That is why I am selecting as a group 1 nautical group. It's nothing but non-direction, right? So like this, we can make it a T table. So independent sample T table, and P value, we can write the interpretation. Another one, there may be a doubt. Suppose in the even the SPSS, just you can see the SPSS, I'm doing the analysis. I'm doing the derivatives. I'm doing the compare means one independent sample test. I'm doing the SPSS now. So I'm just keeping the gender and keeping as a steady habits. Even in the SPS, we have to define it what is 1 and 2, and just keeping 1 and 2, and click on continue and click OK. Now the latest version, I will come to the effect size. So please, okay. So just I'm clicking the estimate effect size. See, now the recent version, the effect size is there. So if I click OK, you can get this the output of the SPSS. So in the output of the SPSS, now you can see this is an output, right? This is an output of SPSS. There's 3 table. Even the cogents table is coming now. Previously, for the old version, you cannot get this cogents. And the people having the doubt. So because the T, we have the 2 T's are there. Whether we can take the first T or second T. Yeah, that is, we have to check with the Levens test only. So Levens test checking with homogeneity, right? So for this for the SPS output, please kindly note. Suppose the it is significant, that F value is significant. If it's significant means equal variance, not what is that, not assumed. Okay, so we can take it from the down 0.82. If it equal variance, if it's significant, suppose if it is significant, we can take it as it's significant at 0.05 level. So that is the reason. Significant means both the groups variance are not equal. Okay, so it seems that it is not equal in the variance. That is the reason I'm taking as the equal variance, not assumed. Suppose if it is not significant, it's more than 0.5. So I can take it equal variance. It seems that both the variants are same. Therefore, this is called it's called Wilks test. So if you take in the first one, it's called T test. The second one is called Wilks test. So in the space it is there. But similarly, in the case of JASP, we have the options. When I press the Wilks, right? Suppose if it not satisfying the equal variance assumed, you can go with the student T test. If the equal variance not assumed, I mean both is differ, you can go with the Wilks test. See here, I hope you are getting the same output, 0.869, 0.820. Similarly, just I'm going to the SPS output. Now you can see this same SPSS output. Are you able to see this output? 0.869, 0.820. This is called T output, student T. This is called the Wilks. Similarly, you can see this output. Sorry, this is an output. So are you able to see this 2 output? The same output is sometimes you may ask whether the same output. Yeah, same output may comes. Right. Now, madam is asking that Janita Chalice, this gain ratio. So gain ratio we can do manually. So that he knows there is a formula. There is a gain score means there may be post scores minus pre scores, right? Then if you like to go with the gain ratio, we have to go with the post scores minus pre score divided by there is a mean scores of the post scores. Like there is a formula that then we can do manually. Okay. But here, what is the advantage? Mathematical U test, as I already mentioned, that is called non-parametric. Suppose it is not checking the normality. So I understood that from the normality analysis, it is not normal. It is like a free distribution. Then we can go with the man-made test. So now I press the man-made test. I hope you are getting this man-made output also. I don't need the student and Wilks. You can remove the student Wilks and you make it man-made only. So man-made test. Right. So otherwise, suppose you want to do all together and finally you can check which is more relevant. You can select all, and which is more useful, more relevant, that you can select it. So you can do parallelly both parametric and non-parametric. I hope Janita Chalice maybe understood. So I'm just doing a man-made test. So the man-made is like non-parametric. It is equal to the student T test, independent sample T test. So when the data set is not satisfying the normality, like QQ plots are not satisfying, or the skewness cut is not satisfying, or subfilability is not satisfying, then we can go with a non-parametric, that's called man-median test, right? So this is the same, but in the case of man-median test, if you want to do in the SPSS, we have to go with the different paths. See, I'm just coming to the SPSS. The SPSS, we have the different path, right? So go to the analyze, and we can go with the non-parametric. We cannot do parallelly the this one, right? A man-median. Suppose we like go the independent sample, there you can find out the see here man-median test, right? So this is man-median classical values, and we can do this process. This is called SPSS, right? Here we can keep it like gender as a grouping variable, steady habits a different variable, and please run it. So I'm done here. This is for the man-median test. Now you can see this man-median test. So this is a man-median test output is coming now. So this is a man-median test. So 82346. The output is 824,346 for the SPSS. The same output it comes here. Okay. So yeah, some changes is there. Okay, but we can see the significant differences. The p-value. Just I'm looking onto this. So yeah, so the p-values look like a same, right? Status. Yeah, now you can see this is scores. This man-median test, this called Vixos and W test status. Which one you want, you can select this one here. So, but the issues that in the SPS, we need to go with a different path. But here is a very simple path to do this. And the other one, suppose you want to do parallelly the normality, click this normality, you can check this normality parallelly here. So there is a normality, you can get the sufferability analysis, see the sufferability normality. And suppose you want to check the equal variance, that's the homogeneity, you want to check whether you like to go with a student tutors or any works, you can go with this. And similarly, if you want to get the descriptive plots, you may get a good descriptive plots like mean scores comparisons. The means of the male, this is a male, how the scores are changing. And this is a quick, actually, this is like a box plot graph. This is a box plot for female. And suppose you want to get the rain cloud plots, you can go the rain cloud plots also. There's a rain cloud plots. So we get a very colorful graphs. Generally, this kind of graph is not available. So here, this graph consists of dot graph, box plot, even the what is that? This is like frequency curve, right? We can get the frequency curve. That is the advantage. Suppose you like to go with the horizontal display, you can go to the horizontal display, where graphs come as a horizontal display. So this you can copy and paste it. Suppose you want to go with the Wilks selfie maximum variation, normally the people checking with the probability, then they can use this. So like this, we can do the independent sample test. Hope you have the doubts in this. Do you have any doubts? Can you move to the another one? So do you have any doubts in this? Up to now, do you have any doubts in the case of independent sample test? So see this, the colorfulness and the way it's coming output is very user friendly. Yeah, thank you, Jignesha. Thank you, Prashant Das. Okay, Prashant Das. Yes, now I move to the first sample test. As already knows that the first sample test is meant for the experimental method, but I couldn't, because I have the data survey method, but I cannot do this. But I'm doing the interface and just showing how to do this. First sample test or dependent sample test, the condition while using the first sample test, the test one mean, the test one mean was test two mean of same group. Okay, so in this group, in this case, we have to go with third sample. Please kindly note, there may be difference among all the three tests. One sample test means if you want to compare the sample mean with population mean, one sample test. If you want to go in the independent sample test, we have a one test with two groups, like male study habits with the female study habits, right? But the post sample test, we have only one sample group, but we have two tests. For example, there may be experimental group. We are comparing the pre-test score and post-test score, or post-test score and the pre-test and post-test written by the same group, like experimental group or control group. So if you have a single group, if you have a single group with the two tests, we can go with the post sample test. So that is, I cannot do this because I have this data in the survey data, but I'm just telling how to do this. For example, if you go to the post sample test, the same kind of SPSS, here it asks the variable paths. For example, I'm just keeping the steady habits as a pre-test. For example, just a thing, steady habits as a pre-test, intelligence as a pre-test and post-test. Just you can add this pre-test, post-test. We may get this. So instead of a pre-test, I'm putting the steady habits. process intelligence, you may get this output. Similarly, if you like to go with the effect size, location parameter, descriptive, and read cloud, so normality, everything you can do. And there is another one, because actually the things which are doing the wrong, because I'm having the survey. So, but I cannot do this, but for the demo purpose, I'm using this tool. The study habits means I'm keeping as a pretest here. Intelligence as a process I'm keeping, and just comparing whether the single group having the control group excellent differences there. And suppose it is not checking the normality, there is a sequence called Wilkerson sign rank test. That is a good thing. Because apparently you can understood what kind of statistics, parametric statistics equal to the non-parametric. What is the non-parametric statistics for this parametric? Man-made neatness for the independent sample test, Wilkerson sign rank for the per sample test. So we may get some idea, some kind of understanding while using this tool. And see, this is a basic understanding. Your tested score should be a continuous. The test score should be a continuous. So this way we can do this per sample test. Hope you get this per sample test. Do you have any doubt in the per sample test now, please? Do you have any doubts in the per sample test? Per sample. So I just started with the descriptive, then I moved to the all the independent sample tests over, dependent and per sample. Now I am moving to the ANOVA. So you know, in the case of ANOVA, there may be a repeated measures ANOVA or one sample ANOVA. Like one group, one way ANOVA means there may be one independent variable and one dependent variables. Okay, just I like to explain this with chat box. So I'm just going with one-way ANOVA. So the condition with one-way ANOVA, I'm just typing in the chat box. So kindly bear with my spelling error. One independent, one IV, and one DV. Okay. So what is called one IV, one DV? One independent variable and one dependent variable. Suppose you like to go with the two-way ANOVA. Two-way ANOVA, we needed two IVs and one DV. Okay, always the DV should be one, so dependent variable should be one. So three-way ANOVA means two independent variable and one dependent variable. If you like to go with three-way ANOVA, these are the basic assumptions, right? Three-way ANOVA means, so any idea what is a three-way ANOVA? How many independent variables? How many? Please kindly type in the chat box. How many independent variables needed for the three-way ANOVA? Exactly, it's a 3. So three-way ANOVA, 3 independent variable. Yeah, exactly. Thank you, Jignesh sir and Sonali. So 3 independent variable and dependent variable 1. So this is the thing. Suppose I like to go with the one-way ANOVA. So it's very simple. What is called one-way ANOVA? Any idea? ANOVA. It's a multi-analysis variance. Okay. One-way ANOVA. I'm talking about one-way ANOVA. Yeah, exactly. Janita sir, what you said is correct. But in the case of one-way ANOVA means multi-analysis variance, multiple analysis variance. For this, the dependent variable at least should be 2 or more. Minimum 2 is needed. Okay, minimum 2 is needed, but one independent variable, and we need at least 2 or more DV is needed. Okay, so if the DV is so high, DV is 2 or more, then it's called ANOVA, right? Suppose two-way ANOVA. Any idea what is a two-way ANOVA? What is a two-way ANOVA? So two-way means, so the way represent is based on the independent variable. So here the 2 IV is needed, and the dependent variable should be 2 or more. Okay, if the dependent variable more than 1, it is called ANOVA, multi-analysis variance. If the independent variable, dependent variable always 1 means you can go with the ANOVA. So ANOVA means dependent variable should be 1. ANOVA means the dependent variable should be 2 or more. So I hope you understand the differences, right? So now can we do this and go to the ANOVA and go to the ANOVA and go to the ANOVA? This is called one-way ANOVA. Even you can go to the multiple ANOVA also, right? Now you can see this ANOVA, the dependent variable. So what is the format? What is the format? Dependent variable. There's another basic assumption. The dependent variable should be any idea? So what is the scale format? It's a scale, exactly. Yeah. So if more than 2, exactly 2 or more dependent variable. Thank you, Jennifer. More than 2 or more, it's called ANOVA, right? Exactly what you said is correct, right? So here the dependent variable I'm keeping is steady habits, for example. The fixed factor I'm keeping is management, because there is a management 3 groups, right? Now you can see this ANOVA table. Are you able to see this ANOVA table? Now you can get this ANOVA table. So this is nothing but between group. This is called within group. Normally the SPS we make it between group, within group. Here it's come the management residues. The residue is nothing but it is a within group. Between group, within group, sum of squares, DEF, mean square, FP. Are you able to see this output? Suppose you need to find the effect size. So even some people like to do the effect size calculation. That's called partial eta square. So here you can go with the partial eta square and eta square. Particularly when you go with a 2-way ANOVA, 3-way ANOVA, we need this kind of eta square. And suppose you need to go with the descriptive analysis, go to the descriptive statistics. So if I click the descriptive statistics, I can get this descriptive statistics. And one more thing, the p-value is significant. If the p-value is significant, means there may be a significant difference between the government aided and self-finance colleges. Therefore, we can go with the post-hoc analysis. So if you go with the down, there is a post-hoc. So you can keep this management here, and I go with this the key. Even the key, there is a effect size, or if you like to done it. So Safira will are born for any. So I request to go with the key. That's more than enough. Go with the key or born for any. And the output same only. So if you click it here, you can get this post hoc test. Even you can get this cogensity also, the effects. So according to this, government data, there may be significant difference. Government self-finance, not significant difference. Aided self-finance, there is significant. Therefore, there is no significant difference between government and self-finance, but the government aided and aided self-finance, there is a significant difference in this case of steady average. Like this, we may get a good output in the case of what is that? One-way ANOVA, right? The one-way ANOVA. Suppose you need to go with the non-parametric, you can get this non-parametric, the Kresker values test is there, right? Suppose you want to check this Kresker values, you can see this Kresker values test. So you may get this Kresker values analysis also. Kresker values, it is nothing but the non-parametric analysis of the one-way ANOVA, right? Now I move to the two-way ANOVA. You got it. So one-way ANOVA, one independent variable, one dependent variables. Now we can see this. So just the output, it is coming to the one-way ANOVA because I have one dependent variable, one independent variable, right? Now I'm keeping gender is another independent variable. So please kindly see here, the dependent variable, you cannot add another variable. Suppose I like to add the achievement, it's not possible to add. We can add any one only. Are you able to see this? I can add any one only. There is no space for the dependent variable. But the independent variable, we have the space. Then what is the meaning? ANOVA is permissible, only the dependent variable is only one means. Okay. The ANOVA means the dependent variable. It's called what is that? It's not multivariate, it's called like bivariate, right? So bivariate, just only one dependent variable. Just I'm keeping the gender as an independent variable. This is called two-way ANOVA. Why it's called two-way ANOVA? I have the two independent variable and one dependent variable. Now we can get this table. Now we can see this table. The management, that's called what is we may call as a main effect. The management significant difference is there. Gender no significant difference based on the p-value, and the manage this called interaction effect. Therefore, the two main effect only interaction effect. The management and gender interaction effect, it is there. Okay. And if you want to do the descriptive and other things are available because I already selected things. Suppose I need to go with the three-way ANOVA. I can go with the qualification. This is called three-way ANOVA because I have three independent variable now. Now you can see this. So the three independent variable means we have a three main effect. We have three main effect: management, gender, qualification, main effect. The other things interactive 1, 2, 3, 4. There is a 4 interactive effect. So we can easily to find from this. Now you can see this is management not significant, gender not significant, management gender is significant, qualification significant, management and qualification significant. That interaction effect gender qualification not significant, interaction effect of the management gender qualification not significant. So we can easily to find the what is that two-way ANOVA, three-way ANOVA. This called normally it's called factorial ANOVA. It's not factor analysis. It's called factorial ANOVA. Did you hear the term factorial? Factorial ANOVA. Just I'm typing. This is called factorial ANOVA. So thank you, President. Okay. So it is like a factorial ANOVA because if you go with more factor, the independent variable is increasing, then it's called factorial ANOVA, like management, gender, quality, because I'm using the three-way ANOVA. Generally, it is called as a 3x2 factorial. If you want to go with the exact name, we can use the term 3x2 factorial. Why? In the sense, the management is the three groups like government, aided, self-finance. Therefore, the three is represent management. Then gender may PG. Therefore, it is called 3 cross 2 factor ANOVA. Otherwise, it's called as a 3-way ANOVA. Did you understood? I hope you understood, right? So we can call it a 3-way ANOVA, or if you want to go with very specific, you can go with 3 cross 2 factor ANOVA. We can use a very specific terms. So this is the way we can do the 1-way ANOVA, 2-way ANOVA, 3-way ANOVA. Otherwise, we can go with a factorial, multifactorial ANOVA. It's called multi. Sometimes the people using called multifactorial ANOVA. So multifactorial ANOVA, right? So they use the different terms. Are you ready for ANCOVA? Are you ready for ANCOVA? So, sir, I will call within 15 minutes. I am the class. Or 15 minutes. Is there any emergency? Within 15 minutes, I will call. Class round or 15 minutes. Yeah. Okay. Yes, sorry. There is a multifactorial ANOVA, and I'm talking about ANCOVA. So similarly, there is a 1-way ANCOVA, 2-way ANCOVA, 3-way ANCOVA, 4-way ANCOVA. Different ANCOVAs are there, right? So I'm just going to 1-way ANCOVA. Anyone kind of brief what is called ANCOVA? There may be a covariate. So if you have one covariate, then that's called third variable. If x, y is an independent variable, y is a dependent variable. If the third variable may influencing the effect of x and y, we have to nullify the effect. Like we have to control the effect. For this, we are using this kind of covariate. Like particularly, we are using for the experimental method to control the extraneous variable, or to check this moderate variable, to control the moderate variable, mediating variable. So like the different names we are using. So in the case of 1-way ANCOVA, one independent variable, just I made this, and one dependent variable, and at least we have at least one or more confound variable. I put the word CV. Okay, confounding variable or controlling variable. I hope you understood. 1-way ANCOVA means one independent variable, one dependent variable, at least one or more. Okay, the basic assumption, the independent variable should be a categorical, dependent variable and the controlling variable should be a continuous. So those are things you must know. So here, if you want to do the ANCOVA, there is a separate ANCOVA path. So I hope you are seeing this. Are you able to see this ANCOVA? I'm just doing the ANCOVA. In this ANCOVA, just I'm going to do the 1-way ANCOVA first, right? So as you mentioned that, suppose I feel that achievement is a dependent variable. Achievement is a dependent variable, and steady habits may be a covariate, right? So now you can see your independent variable, your covariate, like your control variable should be a continuous. This is a basic assumption. You can see this also continuous, this also continuous. And your fixed factor, so I'm just going with the management, independent variable should be a continuous, right? So categorical. Now we can see there is a steady habits is significant, not significant, and management is say significant. Like after controlling, this is look like after controlling this steady habits effect, whether you are checking whether the management having the significant effect, it's significant effect after controlling the effect of steady habits. It is a meaning. So generally in the case of experimental method, we can take it the pre-test as a covariate, or if you are taking some kind of attitude, something you may take as a covariate, right? Here I'm taking a one covariate as a steady habits. Can you know what is the exact name? It is called 1-way ANCOVA. Now I'm just adding gender. So now what is the name? So now what is the calculation name? Anyone give this answer? What is the calculation? What is the calculation I've done it now? So kindly look onto the dependent variable one. And I have the two fixed factors, nothing but independent variable. I have the two independent variable and covariate one. So what's the exact calculation? What is the statistic is this? Any idea? What is the statistic? I've done it now. Kindly give your answer. What is the statistics? Which statistic I've done it? I'm doing now. It is ANCOVA or ANOVA. So ANCOVA means there may be a covariate. If there is no covariate only, it's called ANOVA. Therefore, it is called ANCOVA. It's a ANCOVA only. But what is ANCOVA? Any idea? So you have to decide. Yeah, exactly. Janita Charles, thank you. So it's called 2-way ANCOVA because I have two independent variables. So that based on the independent variable, you can decide whether it should be a 1-way ANOVA or 2-way ANOVA. So now suppose I'm keeping the locality. So it is called 3-way ANOVA. So not actually the locality is not matching. Yeah, I'm just keeping as a qualification. Now I'm keeping the qualification for 3-way ANOVA, right? Suppose I'm keeping intelligence. See here, what is this one? I'm keeping two covariates, steady habits, intelligence, and I'm keeping a 3 independent variable. and one dependent variable. What is this name? Any idea? What is this name? The output, the similar output only. You can see this like you can get this main effect and interaction effect. So can I know what is the exact name? What is the exact name of this calculation? So based on the independent variable, whether you have the covariate, you can decide what kind of. So it is called factor ANOVA. Exactly, it's a three-way ANOVA. Correct. So don't worry because I'm using the two covariate because the covariate at least one is needed. If you go with 1, 2, 3, it's not an issue. Okay, but the factor ANOVA is decided based on the number of independent variable. Thank you, Sonali ma'am. You are correct. So it's called three-way ANOVA. So you have this answer. This residue is nothing but this one. What is this? The residue is nothing but within group variance, right? Suppose you want to go with marginal means rain cloud discrete. Suppose you like to go with the discrete class, you can go with the graphs. Lot of graphs is there. So due to time, I'm skipping it. I'm going to the MANOVA. Are you ready for MANOVA? Okay. So I'm going to the MANOVA. If I go to the MANOVA, now we can see the exact difference between ANOVA. See here in the ANOVA, the dependent variable doing the ANCOVA test depends on the researcher. Of course, based on the research and the variable and the hypothesis, right? It's not suppose in your research work, you have any kind of control variable, any kind of Z variable, the third variable, then you can go with. Particularly when you like to go with experiment method, you can go with this. Exactly correct. So because normally the pre-test influence might be in the case of post-test. So we want to control, we want to nullify the pre-test influences. That is the reason we can use this experiment method. Even the experiment method, people that are using some kind of attitude or some kind of awareness for the specific subject, they're keeping a same covariate. Okay, so it is based on the research. It's based on the research work. So that researcher can decide what is your independent variable, what is your dependent variable, what is your confident variable, whether confident variable it acts as a controlling or it acts as a mediating or moderating. So different roles that Z may be acting. So that the researcher can decide. Can we can use a single group? No, actually, when you go with a single group design, no need for ANOVA and COVA. Okay, because only one group. Suppose if you have more number of groups like control group 2, experimenter group, then only we can go with ANOVA or MANOVA, right? If a single group design, there is no groups, only one group with the 2 tests, then you can go with the per sample titers, or in the case of this one, what is this? You can go with the repeated measures ANOVA. Repeated measures ANOVA, it is a per sample extension. Suppose you have to conduct 3 times exam test like pre-test, post-test, and post or is after this post-related test, you are conducting 3 times of test for the single group. You can go with the repeated measures ANOVA, not for this ANOVA. I hope you understood, no, ma'am. So for the single group design, we cannot go with independent sample test. You can go with only the if you are going with the demographic variable discussion, okay. But if you have single group design, only control experimental group, you can go with only the post sample test, or in the case of repeated measures ANOVA. Okay. Yes. Now I'm just moving to the MANOVA. See here, just I'm showing these differences. In the case of ANOVA, you are getting the dependent variable very small space, only one space. But you can see, and when you go to the MANOVA, and just to move to the MANOVA table, you can see this MANOVA. The dependent variable is very big. You understood? I hope you understood, right? Suppose I'm keeping as steady habits and achievement, right? So I have how many dependent variable? I have 2 independent variable, only 1 independent. That's a fixed factor. Can I know what is the calculation I'm done it now? What the calculation I'm done it now? What the calculation I'm doing now? This is called MANOVA. This is called MANOVA. It is called one-way MANOVA because I have only 1 independent variable and 2 dependent variables. So that is the reason it's called as a MANOVA, right? Suppose you need to keep gender is another one. This is called two-way MANOVA, right? So normally we may get this Pillay test results. Even the SPS may get the Pillay test results only, right? Pillay test results, you may get this. So this is called MANOVA, right? Then similarly, suppose the repeated measures ANOVA, as already mentioned, that it is only meant for the experimental group. Suppose you are conducting a single group experimental with a 3 interval you are conducting the test, or 4 times you conduct the test, then you can go with it. This is like the another extension of the post sample test. So here you can keep the level 1, level 2, level 3, level 4. There's a FOSS test course we have to be upload because I don't have a data sets now for the experimental. I have the survey. That is the reason I'm not doing the demo. But just this interface, just you can upload, you may get this results. And can we go with the correlation? So when I go to the correlation, there is a correlation. The basic assumption should be both this. What is this? Variables are. It will be a continuous. See, just I'm keeping a steady habits achievement. It is a continuous data and just added. And very good things. You may get the exact API, even the SPS also. You may get the whole, even the comparison achievement also. You may get 1-0 like this. So the entire data is output. Now we can get only the diameter. What is that? Only the partial output. This is exactly from the API format. And if I'm keeping some kind of condition on, so do you know what is the calculation done it? There's a two variables comparison, and one is the controlling variable. That's called steady habits. It is called partial correlation. So this is called Pearson product moment correlation. Suppose you don't have any kind of condition on, there is no partial out, then it is called Pearson product moment correlation. Suppose you want to go with the Spearman row, you can click the Spearman row. You want to go with the Kendall's taus, you can go with this. But better because both the variables are scaling. That's the reason I'm keeping a Pearson. Suppose I need to keep steady habits the condition like a controlling variable, the same like ANCOVA. I can go with this one. This is called it's called as a partial correlation. It's partial out correlation, partial correlation. So here, if you want to go with the partial correlated, partially correlated, and one more thing, scatter plot. So you make it a very good scatter plot. I'm just removing this. You can see this PS. You may get this very good scatter plot. Now we can very good scatter plot, and we can see whether it's a curve satisfying the positive correlation, negative correlation, zero correlation. We can check this. Even if you want to check this assume check, you can do the Safra Wilk. It's showing this the things. Okay. So like this, we may get. Suppose you'd like to get the heat map. It is a very good map. So suppose you want to know how the two variables are having the interaction with each of us. This is a heat map. So it's showing this 0.02. It's like a heat. So this is like the magnitude of things. It's like only 0.02 correlations only. So it's not statistically significant. That is the reason showing the p-value is 0.77. It's not significant. Just I'm comparing with the other one. We can try with achievement and steady habits. We can try this. Achievement and steady habits. Yeah. This also not that much of significant, right? No significant outcomes. Similarly, this is a flag significant confident data, but this, which one you want, you can do this. Suppose you want to do the regression analysis, go to the, and just to stop with this 2 minutes and go to the linear regressions. So suppose you like to go with the achievement is a dependent variable, then steady habits as a covariate, and covariate means like independent variable in this case, and intelligence also. And if you want to go with this model, let's say enter model or backward or forward, normally we can go the enter. The similar kind of output may get. See here, there is a 3 outputs comes to the SPSS. This similarly model summary, ANOVA, coefficients. So all the 3 things may get into this. So we can write the interpretation. So here we have the R square value, and the second table model fit. It is not fit. Actually, this is a data is not good for to running the regression because the p-value is not significant. Therefore, we cannot do the further analysis. This particular model, it's not fit for doing the regression. This is the way we can write this interpretation, right? So just I'm going to wind up because now we're reaching the more than the time. So, and suppose you like to go with the factor analysis, kindly click this. That's a principal common analysis, explorative factor analysis, confirmatory. Suppose you want to do a this one, reliability analysis, go to the reliability analysis, right? So like this, the entire SPSS features are available in this. It is much user-friendly compared to the SPSS. So my concluding remarks, so kindly, if you have any doubts in the statistics part, even the SPSS, or in the case of Jamovi or JASP, so I'm sharing my final link. So this is the statistical resources. You can find the entire statistics, things which I discussed now, even some other things I didn't discuss. Everything you can find it from this link. Yeah, now it's a time for you. If you have the doubts, please kindly ask me.
Thank you very much, sir. Dear participants, if you have any query, please make it fast. I understand that sir is a little bit busy. Anybody has got any queries? Okay, since it has to be practiced, then only doubts will be coming. Okay, I hope there are no queries at present, so we will wind up this session. Dear Thiyagu sir,
Thank you so much, first time
thank
sharing.
you very
Thanks
much
to you for giving the
for
opportunity.
accepting my invitation and presenting the session.
Yes.
Thank you very much.
Thank you so much.
We'll end this session now. And dear participants, for you, your certificates are ready and that will be distributed now. And I hope we will be having much more learning session like this in the. Thank you very much.
Thank you. Bye. Bye to all. Bye.